In this exercise, we're going to practice the vectorized string operations on a dataset that contains 10 earning calls. So an earning call is a public presentation and a QA session that companies do on a quarterly basis. Basically, a representation from the company executive team present on the company's earning, hence the name earning calls, as well as future plans, and they also take questions from the audience. This text is transcribed and usually compiled and put in public data sources. This dataset has been assembled from multiple of these public data sources, and it has 10 earning calls. If you take a look at one of the text of these earning calls, for instance, let's take a look at the first one. I'm going to print data lock 0 text. That's the text of the first earning call. And you can see that this is basically a large amount of text. It's the transcription of this whole presentation plus the QA sessions. This data present a wealth of data for text mining because it enables us to probe aspects of the company leadership as well as future plans, relationships with other companies, environment, and so on and so forth. So it's been used extensively in digital marketing as well as in business research. For the purpose of this exercise, we are interested in doing some basic processing of the text of these earning calls. Okay, so first let's calculate the length of each one of these earning calls, the text column basically. The question is asking us to create a new column called length in the data frame. So the first step is to pull the text. We would like to use a vectorized function, so we need to pull a series here, which is data text. Data text will pull the column text from the data frame. Next, we want to use a vectorized string operation, and this operation is the function length. So data text strlen is going to give me the number of characters, the length of each text of these earning calls. Now the question is asking us to create a column length in the data frame, so I'm going just simply assigning it to a column in the data frame called length. And that's basically it. The next question is asking me to count how many words are contained in each one of these texts. How do we get to the number of words in the text? Well, if you take a look at text here, it's a series and the values are string. So one way to get to the words in the text is to basically count the white spaces in each one of these strings. We also need to count not only a space, any white space, including a new line and a tab character and any white space character. An easy way to get to that is to basically split the string, because split by default is going to split around white spaces. So I'm going to do str and split, and now I will have, instead of a string in each one of these of the series values, a list of strings. You can see that we have Zoe's, kitchens, comma, ink, so on and so forth. Indeed, if you take a look at the very first one, I'm just going to peek at 0. You can see it's a list of string values. Alright, so to count the number of words, then I need to calculate the length of each one of these lists. This is again another vectorized string function, because some of these vectorized functions work on sequences such as list, and that's the case for the function length. If I do .str.len, I'm going to get the length of each one of the lists, and that's going to give me the number of words in each one of these earning calls. Finally, I'm going to create a new column, call it words, in my data frame. So I have the length in characters, and I also have the number of words here. Alright, are there any emails in the text? An easy way to check for emails is to check for the @character. Now, generally speaking, probably it's desirable to write a fully fledged regular expression to check for the email. A kind of a quick and dirty way to do it is just to look for the @character here. So what I'm going to do, I'm going to pull data text again, and I'm going to do str contains, and I'm going to look for @. And it happens that none of these text contains @, so there are definitely no emails in the text. So again, this is not a bulletproof test because you may have like a mention, like a social media handler, for instance, that contains but there is no email. Anyhow, since all of them are false, there is no need to do that further check. I'm just going to report that all of them are false. Now, if you want to answer the question specifically, are there any emails in the text, and all of them are false, we can assign that to another column called email, or we can, if you want just one answer, are there any emails in any one of these texts, we can use the function any, and it will be false. There is no emails in any one of them. So I'm going to skip 4, extract these emails because there are no emails here. We will see in a future exercise how we extract emails. It's very similar to extracting any regular expressions, text matching any regular expressions, such as in this case, we want to extract tickers and stock market from the text. You can notice that in each one of these texts, there is a reference to the stock market and the ticker of the company here. So that's the pattern we need to match. We need to match a bunch of characters and a colon and a bunch of characters, and all of them happen to be in parentheses. So I'm going to do data text str. I'm going to use the function extract here. Now the function extract will take a regular expression, and that regular expression will be matched for us. So let's say I want to extract any bunch of characters and a colon afterward. So I can do dot standing for any character plus and then a colon. And I need to provide a capture group here because extract is expecting us to capture the pattern or a bit of that pattern in a capture group. So I'm going to capture the dot plus and then the colon here. And what I get here, I get all of the characters up to the dot in my capture group. Okay, so including the stock ticker itself. Now, to be more specific about this, it's basically the stock market symbol here, not the ticker itself, the stock market symbol here. I need to exclude all of this stuff here. And to exclude all of this stuff, I need to indicate that, well, those dots are preceded by a parenthesis. So that's what I'm going to do here. I'm going to say, okay, look for a parenthesis. But because parenthesis has a special meaning in a regular expression, I'm going to escape it. This means look for the real parenthesis, capture everything afterwards, and stop at a colon. That will basically give us the stock market symbol here. How about the ticker? Well, the ticker is the opposite, so we can do extract from the colon to the matching parentheses. We obviously can do that in another operation, but extract can extract any set of groups that we provide in our regular expression. So I'm going to do it in one step here. I'm going to say, okay, now my second group in those two parentheses is going to be any character repeated. Okay, and I'm going to end with another matching parenthesis here. Now I have two matching groups. One of them is the stock market, the other one is the ticker. Now I can be more specific. Probably it's fine here, but maybe I want to say it's A to Z here instead of a dot. A to Z. That will be the same here. But basically I'm saying look for A to Z repeated, colon A to Z repeated, and you need to have a parenthesis here and parenthesis there. Well, now the last step, I just want to give those columns more meaningful names. So there are two ways of doing this. I can either assign this to an intermediate steps, and then change the columns names to be that. Or I can go ahead and assign, because this is a data frame, I can assign it back to my original data frame, very much like assigning a series, except that I'm assigning it to two columns in the data frame. So what I can do here, I can say, okay, data, and the first one is going to be the stock market. I'm going to call it market. And the second one is going to be the company ticker is equal to that. So if I take a look at my data now, it contains the market and the ticker. Okay, this probably belongs here. Now the last question is asking us about the sectors that are more verbose, that use more words than others on average. If you take a look at this data here, you can see that companies belong to different sectors. So we have 2 companies or 3 companies in consumer services, 3 companies in technology, and maybe 1 in finance. But you can see we have multiple sectors, right? So an easy way to do that math is to do group by sector. That's the sector, and then count. And you can see that we've got 1 in capital good, 4 in consumer services, 1 in finance, and 4 in technology. Okay, now this question is asking us for sectors that are more verbose, meaning use more words than others. So what we want to do, we want to group by sector and pull the words, because we want to aggregate and do the average number of words per sector. Okay, so that's what we get here. And obviously you can see that technology is the most verbose, followed by finance, followed by consumer services and capital good. What I'm going to do with this series is just simply sort it by values. And I'm going to make ascending false here. So we get sort values ascending false. We get it sorted by the average number of words in each sector.